Oh, sorry. Good morning. So yeah, I haven't been streaming for a few days because I've been sick, and I'm still not um, back at it. I guess 70% maybe, Mm, but I wasn't completely out. So I did try to find time to watch some YouTube videos, and there's so much going on. Um, Discussions, research, papers, and I'm so happy to see all these very, very intelligent people being able to convey all this information and all this research in an accessible way. Especially, I was watching like Andre Karpathy um, videos on what are actually LLMs, how does the tokenizer work, yeah, actually implementing stuff, and it's very, very enlightening. And I also watched some uh, videos on research on like, are these LLMs actually capable of reasoning and planning? Um, and Yeah, a lot of other stuff. So that was really nice, and it gave me some reflections, and it also gave me some ideas. So I thought we could maybe start kind of going through some of this, and I might have to drop out. It depends how I feel, but we'll try. We'll try. So when we worked on this last time, we basically um, conceptually separated some things so that we rather have this agent router where we have these different agents, and the agent router is basically kind of like a browser router in the sense that you will kind of push messages onto the history stack, and then it would route. Well, yeah, I guess you can't really compare it to a browser router, but it has the same elements. Like you're pushing something onto the history stack, um, and then it's like conveying that to an endpoint, which is the agent. Yeah, maybe this is a good analogy. To an endpoint, which is an agent, the agent response shows you something, um, and then you can continue like navigating in that sense by pushing more messages onto the stack. Yeah, so you can think of the agents as like different routes, and then you have a history, which are the messages. So it's kind of relatable. But the good thing is that we now have the on agent completed that we can use to do stuff when an agent completes its, or when the route is done or the agent has responded. And then we also have the actual state. So we have, let's draw app state. So the app state is what controls the flow. Like this is what the app is, and it includes like which flow are we in, which then decides which agent router should we be using, and so on and so on. So you have like one agent router per flow. At least that's how it works now. Yes. And then, so one of the points is when an agent completes, and then you also have when the user tries to send a message, we can also evaluate by the application state what we want to do. Like which endpoint should we send that message to? Or what agent should we send that message to? Which is great. So before going into like the reflections on LLMs and stuff, I had this idea of, because I mentioned that the Assistance API has a new version, and I think we're going to change back to that because now I'm using the completions API. So that means whenever the agent router wants to send a message from the agent, there's like a different like on send prompt. That's basically it. So we have this on send prompt, and when that runs, we send it to the completions API, and then we handle the message in the agent router, like handle the response and all the function calling and everything in the router. So that is part of the messages history of the router. But we don't have to send it to the completions API. We can also send it to the assistance API. And the cool thing about the assistance API that I hadn't considered is that what if we think about each agent having their own thread? So the assistant, when you create an assistant, you might conceptually think that you would need one assistant per agent, but you don't actually need that, because the assistant is kind of like a wrapper around everything. You can customize everything in a thread, regardless of what you configured in the assistant. So if you have an instruction in the assistant, you can override that instruction in the thread. You can override the model, you can override the functions, you can override it if it should be a JSON response. Like, it's kind of like a completion. So we can have like a single assistant still, but then we create a thread per agent. So this is something we would create on the outside in the actual app. We would generate the thread per agent. So basically what we would need to do is keep a reference to, like, the flow has like, I'm not sure how we would do that, but we would at least have a reference. So whenever an agent is completed, or I guess whenever we want to send a message to an agent, anyways, there has to be a reference to the thread, so that whenever we are asked to send a prompt, we send that prompt to the correct thread. That's the point. Yeah, so maybe that's how it would actually work. So it doesn't matter about the user prompt. The user prompt just goes into the router, and then the agent wants to send that prompt somewhere. And so in the on send prompt, we check the agent. Do we have a thread for it? If not, we create that thread. And then we send it in there. The good thing about this is that we'll keep that thread going, which means that the thread has a context window. So we don't have to worry about that. We're kind of isolating the context window per agent, which I think is a good thing. So that you can imagine the experience we have now, where we have the idea, and then you're kind of saying, I want task management, for example, super ambiguous. And then you have the first agent suggesting some user stories. But then you want to, then you can use, since that's a JSON response with a list of actual user stories, you can use like interaction points in the UI to manipulate that. But you can also just write back to the agent if you want to do that. And previously with the completion, or what we have now with the completions API, is that we have to manage the context window for that. But having a thread, we don't have to do that. We can just have a natural conversation where it makes sense with the agent. That doesn't mean that, like, I want to push away from having conversations. I want to create very specific conceptual data structures that make sense to... Yeah, let's talk about that shortly. So the point is, this is something I want to do, but I don't think we should do it necessarily yet. But it makes a lot of sense to me that each agent has a thread. Yeah. With their own, but they still have their own functions. They have their configuration for JSON response and everything. Let's see. Yeah. Okay. So what about these reflections? Where should I start? Maybe I can start up here. So I was talking about like this 20% planning and then execution. But the thing is that, which I wasn't like quite aware of, is that an LLM, well, I was kind of aware of it, but not to the level of detail that I have now, which is that when they create these language models, they are document completers, which I kind of knew. Like it's just predicting the next word, right? But what wasn't obvious to me is that they are literally document completers, which means that when you have the base model, you can't ask it things. It will just finish documents. So it will just try to like finish whatever you're saying. It doesn't have any understanding of assistant user. So when we say that you have like an assistant, that's a fine tuning of the base model to ensure that you actually get this format of a conversation of an assistant and a user, which is interesting to me. So it's still like a, but at its core, it's still a document completer. So what I think is interesting about that is that when completes documents, that's like LLM base completes documents. So what's interesting about this to me is that when we moved into actual assistant LLM, fine tuned for conversation format between assistant and user. When we did that, we made it look smarter. Like the feeling as a user or as a human being experiencing this is that it seems much smarter than it actually is, because you're asking a question and it's answering you. Unlike here, you would write some text and it would just complete the text kind of. I've never looked at the response from like a base model, but you wouldn't have a conversation with it at all. So this is the first thing, is that we apply so much more capability to it just by the fine tuning, the format of the response. It seems like it's listening to our question, it's reasoning about that question and giving us a response, but it's not doing that. It's still just completing documents. So what I don't like is that we also now have what came kind of after this, as I understand it, is like levels of prompt engineering, where we now kind of do things like chain of thought, instructions, like, and we have these concepts where we embed or we apply concepts to the LLM that's not real. It does not have a chain of thought. It is not able to follow instructions. That's not what it's doing. But we are kind of putting these labels, and yeah, it's very interesting to me. I think it's a much healthier approach to just think of them as what they are. They are document completers. So you need to find a way to structure a document so that like its predictions for finishing it fits with the outcome you want. I'm just reflecting here and kind of trying to have the right mindset to get what we want. So what's interesting about this to me is like when we look at this approach of overall what like planning and execution, that's very different things. And when I say planning, I don't mean to actually reason and plan. I mean like literally reduce ambiguity. I actually mean reduce ambiguity when I say planning. And that's something else than executing. It's like it's a different document you want to complete than when you execute something. Those are like different kinds of documents you want to complete. So when we take that into like the app we're working on, when you have an idea, the kind of document I I want to think of these as documents. So what is a good finished document for each of these steps, which ties into um, these specific concepts we apply, these specific prompts we create for the agent. So when you have an idea for a feature for a web application, that's like there's a very specific formatted document that explains that very well with as little ambiguity as possible. And it's also structured for the next step. Like, yeah. So what I'm, you have to excuse me. I've had 3 days without all of this in my head. But I hope it kind of makes sense. So when you have an idea for a feature for a web application, a user story is a really good formatted known concept for expressing that idea. So that's what we're doing in the first step. But that's not enough to go and actually execute on it. There's too much ambiguity still. So then you have another concept, which is like behaviors, for example. So what are in these user stories, what are the behaviors? So that could be a list. And then you have key user actions, for example, which is like what are the actual actions the user is going to do from these user stories. And that reduces ambiguity even more. And then you have what are the design element or the web elements we're going to put into play here, and what are they going to look like. That's also to reduce ambiguity of that idea, like your expected outcome. So the further we can create a how should I put this? So we want to end up with a document here that has as little ambiguity as possible from what the user has in their mind to something that an LLM can predict the next thing to do from. And there should be as little, like, they should be as close together as possible. And how do you actually do that? Because that, I think that's the biggest problem. It's like what you have in your mind and your expected outcome from the LLM, and what the LLM actually produces. And at this point, we're doing something that the LLMs are really good at, and that is generating, basically hallucinating. Like, we don't want it to copy paste something from before. We wanted to hallucinate suggestions for user stories and behaviors, and they should be related. Like like hallucination isn't how should we put this? So an LLM always hallucinates. That is the output. It's like I don't think I'm done reflecting on LLMs yet. You know, we're gonna jump back to this because there's more to this. So at the end of the day, you have to excuse me. At the end of the day, it always hallucinates. The response of an LLM is an hallucination. You can't get away from that. It comes up with it. It's generative in the sense that it doesn't generate facts. It just comes up with it. So I think an LLM is much closer to what you see with DALL-E, for example, image generation, than what you would see. Well, I guess we don't really have any kind of AI that actually generates factual content. I guess you could say maybe the code interpreter. Like, if you think about the code interpreter, even that can be wrong, of course. Yeah, no, I don't think we have any good analogy to that. But my point is that an LLM is closer to the creative nature of DALL-E than what it is to something factual and correct in terms of output. So that is why an LLM is super awesome at creating stories, and so on and so on. But it won't like fact check itself unless you actually apply some more layers to it. So that's really important to keep in mind, is that it just comes up with stuff. Yeah. And yeah, I think that's hallucinates more like DALL-E. Okay, and that is our basis. So when we move back to our idea, that's a good place to put LLMs. Because you want it to suggest user stories. You want it to suggest behaviors. And you can't fact check those. This is more about what the user thinks about it. Does it resonate with the user? So it's a conversation between the user and the LLM to reduce ambiguity in the idea of the user. So the user is the evaluator of these creative suggestions that are like, but it's not like completely random suggestions, right? It's related to what you're saying, but they're still creative suggestions. So the document we end up with here is not correct. It's not, yeah, I'm trying to find a good term for what is a document that is like creative and what is like factual. Maybe I should just call it that. Like, is it a creative document or a factual document? And an idea is definitely a creative document. But then we move into spec. Like, we're actually going to specify what we want to do. And this is where it gets so much more tricky, because this is like factual. There are certain things you can do and cannot do. And this is where, yeah, it just gets a lot trickier. And I think it requires a lot more. It's almost like when you have an idea, so maybe it's kind of like a ratio. So in the idea, you have like a product manager, engineer, UX engineer. We're going to have a designer in there. And then you have a tech lead. And the only agent that actually checks, like validates, is the tech lead. So you're like 4 agents coming up with stuff, and then a fifth one that's actually like going through it to validate it. And it doesn't actually validate it. It kind of just goes in and tries to find ambiguity. So it's not even factual validation. It's just creative validation, really. But when you get into spec mode, we're going to describe exactly what we need to do. So as an example, we need to find what files are involved related to the implementation. Where are we going to implement this? What files are we going to implement it in? And where in the files are we going to implement it? And then it might say, okay, this is where you have your Firebase logic. This is where you have your main component. But it's not able to reason about like their relationship in any way. It doesn't understand import statements. It doesn't understand that when you write export in the Firebase file, you can import that method in the other file. Like it doesn't actually understand that. So I'm wondering, like, how do we? I just think there needs to be a much deeper validation here. it's almost like, do you need a specific agent to validate imports, for example? Exports and imports. And what is the format of this document that makes it possible to actually execute on it? Like if you have a specification and you give that like a full specification, like these are like the specific things that needs to be implemented, these are the files even. If you give that to an implementer, is that like a good format to implement on? Or should it be more like in specific tasks? So you give one task at a time to an implementer. Or is there like, how do you make an LLM write the correct code? What is that document? Like if you think about documents in real life, what kind of documents results in the code that we write? Like we have like linear issues, but they don't. There's a lot of ambiguity in a linear issue compared to what you actually implement. It's almost like, I was even thinking about, what if the specification goes through the files that needs implementation and writes comments to the contents of those files, and that is the specification, and then you just give the files with a bunch of comments, and that's what the implementer executes on. Like that seems to me to be a much closer specification to actually writing code than what we know as humans of that is a specification. So that, I think that would be really interesting. This is the thing I'm reflecting on. I don't think it makes sense to just ask it to write a specification from some user stories and behaviors and then expect that to just be good code. It needs to be something more than that. So it would be interesting to like give it these user stories and behaviors and like key action points or key actions, and then ask it to go and find the related files and write comments in the code of where like these user stories should be implemented, just to see the result of it, because at least it gives an indication of its reasoning, which is not reasoning, which is, it's really just taking advantage of its prediction model to enhance the likelihood of writing correct code when it actually does implement it. Yeah, I think I want to try that. So spec find files and write comments as implementation plan. I think that will be super interesting. Anyways, I've been rambling a lot. I'm really sorry about that, but I kind of been constipated in my brain, having all these thoughts, and I didn't explain it very well. But I think the thing is, I'm not very like, after this weekend, I'm not very I feel more realistic about what LLMs actually are and what they can do. And maybe suddenly a new model comes and it suddenly has this ability to reason. But you don't have to go through a lot of material to see things like another thing that I saw, which resonated a lot with me, which is because I read the book way back when, which is how we work, our brain works. So our brain has, I think I'm going to put that over here. So if we think about the brain, which is more a circle than a square, we have two parts to our brain. We have something we call system 1, and we have something we call system 2. And system 1 is our primary mode. It's the primary mode of our brain. And it's, you can say it's like, it's the part of the brain where you don't think about what you're saying and doing. It's like intuition. So it's like a intuition, fast compute, little energy, small amount of energy. Fast compute, little energy. Yeah, whatever. Did I have intuition? Intuition. That's fast compute, little energy. And then we have this other part of our brain, which is actual reasoning. And we need, like, the point is, our brain is trying to use as little energy as possible. That's just from nature. It makes a lot of sense. So that's why we have system 1 as our primary mode, because it takes less energy. And we react faster, but it's not factual, right? It's not correct. It's just, it's unreliable. Yeah, you know what I mean. But then when we need to, and when we are incentivized to, the brain will trigger system 2. And this takes more energy. It's kind of course, just the opposite. It's reasoning, long compute, planning, and like you have ways of thinking where you can like put things aside, you can think about something else and then go back to the thing. Like you have memory, planning, temp memory, I guess, planning. You have all these complicated things that humans can do. It's kind of what separates us from everything else in nature. It's our system 2 thinking. Yeah. The point is, LLMs is only system 1. They don't do any reasoning. They don't have like the ability. I don't think I should say temp memory. It's like, there's a term for this, but I'm not a scientist. It's like when you have, maybe that is part of reasoning. Let's just do reasoning and planning. LLMs is system 1. It's just intuition. It's fast compute in relative to system 2, and it takes little energy compared to system 2, which is why it's so unreliable and can feel random, and so on and so on. So if you actually want to do, if you want an LLM to do things that we humans do in the real world to solve problems that requires reasoning and planning, LLMs needs the same capability, and they don't have that capability. They don't have reasoning and planning. But that doesn't mean you can get very far. But I think we have to be it's important to, or healthy to have that perspective. Because if you don't have it, you're giving the LLMs what's it called? Benefit of the doubt? Or what do you call it when you kind of put stuff into something that's not there? Anyways, I think that's like a good summary of what I've been thinking about. But yeah, we're definitely getting fooled by it. Like when we ask it to create a plan, it will create a plan that looks correct. Like it has the format. It knows what the format of a plan is, but it's not able to reason about the contents of the plan. It can just derive it from its, like, create suggestions from its training data. But when you have unique, like, problems to actually solve, it can't reason about that. Anyways, so the way, okay. You'll have to excuse me. This stream is only for me. I'm all over the place. So what I think we need to do is to find a way to kind of simulate System 2 when you actually go into something like a specification. And when I say simulate, I don't mean to actually simulate. I mean to, like, we're not going to implement a reasoning and planning concept anywhere. It's just to like prompt and build up a set of agents to kind of support the idea of a System 2. So you would have basically what it means, you would have way more agents for validation. Because that's kind of what System 2 is. It's, instead of just giving your raw thought, you're evaluating that thought. The problem is that yes, I guess that's what I mean by simulating. It's like you're not actually implementing a System 2 of reasoning and planning. You're kind of just adding more System 1s. So you're just adding like more random perspectives or generated perspectives on I don't know what I mean. But yeah, okay. So I did actually do some coding as well. So we should be in a state now where we can by the way, did I delete the assistant thread? No, I still have it. Nice. Okay, so you give this ambiguous thing, you get some user stories suggested, and you can interact with them, or you can approve them. And then it goes to the UX engineer, which what does it do? Yeah, we're gonna change this. I have quite a complicated schema for this now, but it creates key actions. So write a task description. The user inputs a description of task I want to keep track of. It should be a text input field. Now these are like objects, but it should be just strings. We're gonna fix that. But these are the key actions, and then we approve that. It goes to the engineer, and it explains the behaviors in the actual app from the perspective of the application. So this is perspective of the user. How does the user interact with the app? And then this is from the perspective of the system. How does the system react to these interactions? And these are like 3 different lists that are related, that just has different perspectives. And what's interesting to me about this is like maybe they could just be, these are just parts of a document. So we can keep it as a conversation for now. I'm going to add headers to kind of start playing with it. But I'm actually thinking that when you approve it, we kind of show, oh, these are the user stories. And then we kind of add to an actual document. But another thing we're going to try, which is going to be exciting, is that we're going to try to create a designer agent, which is actually going to write some code for us. Because I was thinking about, like, what is the best possible way to reduce ambiguity of what the user sees in their head, right? So you can try to describe it with text, but I don't think that helps. And I played around with this and I was like, what kind of format? It gives you the possibility to describe the UI of a web application without actually implementing it. So you have to look at this. It's kind of cool. Jet. Is this where I played? Yeah. So then I thought about, what about ASCII? So could you create an ASCII of a web interface where I can write the description of a task, click a button, and this is what it came up with. And then I was like, blah blah blah. Yeah, and then I saw it was the add task button was like underneath instead of next to the input, and I just asked it, could you put the add task button next to the input instead? And it actually does that. So I find this really interesting. It could be a good way to like mock UIs. It's using ASCII. And then I say I also want a delete button next to each task, and it does that, which is really cool. And it's super cheap, right? And you can't use Dolly for this stuff. Because what Dolly does is, like, it's too creative, right? I asked it to take this ASCII and then change it into an actual, like, that doesn't work. So I find that fascinating. ASCII is definitely a way to visually describe something that language model is good at using. But then I thought, why not just use Sampack and actually write some code? And you can actually see the UI. So instead of actually implementing something in the app itself, we're going to run the code in the sandbox. And you can actually see the result of it. So that's what we're going to play with first of all, because I think that's really, really interesting. Let me just check. Cool. So what we're gonna do is we're gonna look at the code, because I don't think we actually have anyone else here now. We have the tech lead. I'm just thinking about UI here. Yeah. So what I think we're going to do is we're going to remove this Excalidraw and we're going to create a markdown. It's going to be a document and it's going to be our idea document. And we're going to, as we approve here, we're going to fill up this document and show it. And when the designer suggests something, they're going to suggest it in the chat. It's going to be too small probably for an actual user experience, but it's going to be good enough. But then as you approve it, we're going to fill it into the document. Yeah, this is going to be interesting. So what's important here is that let me just check on agent completed. Yeah, I don't think we're actually filling up the aren't we doing that? Oh yeah, here's on agent completed. So currently we are just filling up. What should we do first? because now we need this state, because now our agents are stateless. So we need this to ask them to change things, but we can drop this if we implement the assistant thread. I'm very curious about that, using an assistant thread instead. But okay, let's not do that now. Let's go in and look at the type. And what we're going to do is we're just going to give... Yeah, so we're going to change this. User stories. And we're going to give it a status. Approved. Pending. How are we going to do this? Like there's a last status here, which is like hasn't been created yet. Idle. Like it hasn't, we haven't done it yet. Like there's different ways we can organize this state. Data pending or status idle. I'm just gonna call it idle. Then I'm gonna remove this. We're gonna have behaviors. It's gonna have the same structure. We're gonna do the same. Yeah, we need to fix the key actions. They're gonna be strings. Cool. And then we're gonna have, let's see, POC, proof of concept, or what should we call it? Could you call it MVP? No, it's not MVP. POC, proof of concept. And this is just a string because it's just code. And okay, great. And then we're gonna, let's see here, start planning clicked. Yeah, we can drop this for now. Let's just remove it. Let's see what we'll do with that later. And then we are in on send assistant message. So state user story status equals pending, idle, or pending. So here it will be much easier with the threads, because here we don't really need to have we just need an approval state of the user stories. We didn't have to actually keep them. We could rather do, when you click approve, well, yeah, I guess we still need a pending state. Yeah, no, it wouldn't be fixed. But I guess it's, this is a little bit, so the point is, if it's idle, we want to pass like an empty array, because we don't actually have any user stories. Why do we have message here? It should be empty. And then let's see. Else if state.user story status equals pending. So this is when we're like sending feedback, kind of. But then we already have some user stories here. We can send that data. I don't think feedback should be populated actually. Oh yeah. Like that. Yeah, so currently you can only talk to the product manager. I haven't really created the feedback loop of the other agents. And then let's just remove all of these. Messages should be there. So behavior, status, idle, key action, status, idle, and user story, status, idle. So we don't have anything. And then when we actually start getting something, we're gonna say user stories will now be pending, and these are the user stories. Like that. And same for engineer. Status pending, and then data is behaviors. Pending. Data is key actions. We're gonna change the typing of this. And then when we yeah, and then when we actually on approve user story, this should be like on approve. So yeah, state user stories status equals pending. We're going to change that to this state equals this state. Oh yeah, sorry. Close this state, close user stories. This is now going to be approved. Oh, what did I do? Wait, what did I do? Oh, sorry. This state flows user story. And then user story status is approved, and then we actually have the data is still the user stories data, and now we're passing the information to the UX engineer, and then we have to do the same here. So state UX engineer, that's key actions. Status equals pending. So if that's pending, it means that we need to update that to approved. So this would be key actions. And then we pass that data to the engineer. And then we'll have to do the same. If states behaviors status equals pending, we're going to do the same thing. We're actually going to pass it to the actually going to pass it to the designer. So that will be behaviors. That's approved. And then, yeah, we're going to have a designer there. I also refactored the UI, so we have more flexibility now. to do what we want. But okay, let's first go in and fix the JSON schema of the UX engineer. You see here we have, and this should just be an array of string where type of action, description, and UI elements involved. I think I got some bad results on this, but sorry. Cool. Now that should be fine. You should be happy. I'm happy. Let's go into the UI and look at the user stories flow, and let's comment out the whole Excalibur thing. Because I don't think it makes sense to create UIs and get a description of it. When it comes to UI, you need a more hands-on, like it's too ambiguous, right? You're creating this Excalibur, which is very ambiguous in the first place. And then you're just adding a description of the Excalibur, which just makes it even more ambiguous. But what we're doing now is that you're actually going to see the code that represents the UI you're actually going to interact with. This is kind of annoying. Let's see. Let's remove this. I wish I could do like... I'm really bad at commenting. Like... oh yeah, so this should now be... This should just be key actions. Oh. And now we're not going to use this. We are actually going to run the markdown. Yeah, it's just missing contents. And now we're going to look at the actual... is it editor store? No. User stories store. So we are gonna add, let's see, what are we gonna do? This is text, so we need to do this. And now we're gonna say idea. And then we're gonna have user stories. State, user stories. And we're gonna, yeah, we need to check the status. So if it's approved, we're gonna iterate over them. Map, user story, like that. And then we're gonna join them by line break. And if we don't have them, we're not gonna put anything in there. And then we're gonna do exactly the same thing for key actions, behaviors. Just gonna change key actions, behaviors, key action, behavior. Cool. Yeah, so we're gonna change. Let's just remove this for now. Let's open and let's go through. Oh, oh, let's fix that. It should be, of course, like this. And let's shove this into oops, div with class name p like 12 or something. There we go. Yeah, okay, so let's see what's happening now. So when I insert my idea suggestion, my name or category to my cart. Oh, I did. What did I do now? You got a little bit. Oh, it didn't actually pass in the message. Why didn't it do that? Oh, was that the feedback thing? Yeah, why do I call it feedback? Shouldn't this just be the... yeah, I think I... sorry. Product manager. So we're taking... oh, we're putting feedback in here. But why am I putting... I'm confused by my implementation. This is a good thing, like designing APIs, because I'm passing the actual message in here. Where does that come from? Generate prompt. Oh, sorry. It should be the opposite. I remember now. Oh, where are you? So this should be undefined, and then feedback should be the message. Sorry. Yeah, I should change that because this is confusing from the outside. Because you can't, currently you can't have both a prompt and, like, this is the input. Yeah, that's confusing. I have to blow my nose. Let's just try this. Oh, and now it's not. Oh, okay. So this is what's put into the into the message as the actual prompt, and this feedback is like part of the generated prompt. Yeah, sorry, I remember now, but that's confusing. That wasn't intuitive to me, so we need to iterate more on that API. Blah blah blah. I approve. So when I click approve now, we should see the user stories pop up there. Yeah, that's kind of cool. And then the UX engineer. Yeah, because this is the thing. This is what I experienced. It wouldn't follow the schema for some reason. The UX engineer. And this is, yeah, I think it gets confused by this. I'm gonna drop these instructions because these instructions are, as I said, like it doesn't follow in instructions. Like you can't say these are the instructions and think that it actually does them. It's just trying to complete this document. So I'm gonna try without these instructions and just using the prompts. I kind of don't want to have any instructions. I feel like it's almost like it should be domain. What's your domain? So yeah, you're kind of telling like who are you and what's your domain. So you kind of narrow down the context. That's fine. Like narrowing down the potential like it's gonna predict the next word. Like what's the best way to like narrow down the prediction, and that is to give it like some domain. What's the domain it's operating within? Like what's the vocabulary domain? Think about it as, yeah, I think that makes sense. Like how do you narrow down the vocabulary domain so that the word prediction is at least related to a specific domain? So having instructions, to me, it doesn't make sense conceptually. It's more like narrow down to a domain. Yeah. Let's see if it behaves better now. Like I'm finding this AI stuff to be kind of the perfect challenge for me because it's language. I don't like consciously, or I even tell people that I'm fascinated by language, but I am. How and like the complexity of language and like conveying intent with language. Just I love writing small like SMS messages to and kind of create a sense of rhythm and mood and stuff like that. And that's not been part of my coding endeavors. So okay, let's approve that. So it's like deeply thinking about language, and then also using coding to create an experience. Please help me derive key user actions from these user stories. So what I find interesting here is that the schema says that it's a string. That includes a description of what the user does and UIL. I wonder why. So this can be like it's training data. So all the training data of key actions, like related to key actions, they actually are described not as like just a list. They have these very specific labels. But I find it funny that it overrides the intention of, it overrides the schema. That doesn't quite make sense to me. Let's see if we can get it too. There's another term. No, I just read about or I saw like a YouTube clip. I didn't have time to watch it, but it said something about like disrupting GPT-2. I didn't quite get to what it actually is. What is it? Oh, what did I do? Oh, there we are. Why does it add type, description, UI elements? You know, I'm gonna call it interactions instead, because I have a feeling this is gonna be a cool little experiment. Key interactions from these user stories and create a list of interaction that includes the description of what the user does and UI elements that are involved. Maybe it's, yeah. Maybe I also hear description of interaction yeah, let's just call it description of interaction, and we're gonna change the type here to have interactions. That's kind of cool. It kind of fits. Let's see, interactions. Should I use rename symbol? Interactions. And then also in our UI, we need interactions. Interactions. Do we have another one? Oh, interaction. What's the mind-blowing thing about GPT-2 on Chatbot Arena? Is it like very good, or? And how is it good? Using, okay, this is nice. This is what I wanted. Cool. Nice. Behaviors. Oh, I need to make this scrollable. Nice. Okay, we're in a good spot. We're gonna find Sampack, and we're gonna implement that, and we're gonna see what it does. So let's just add H full or screen. Scroll. How do I do that? Overflow. I mean, overflow. Y auto. Overflow. Y auto. Okay, I'm really excited about this. So, yarn and Sampack. I want to get going. Getting started. So this would be yarn and code Sampack React. And then the thing is, we only want the preview. I think I can configure that. Let's see. So this is gonna happen in the chat. This is gonna be so cool. Let's create a designer first. Oh my god, I'm excited. I'm officially excited. Role designer. So for me, a designer is let's just give it instructions. You are a web application designer who knows how to, you know, we're just going to use the prompt for this. I'm going to drop the instructions. I currently don't believe in instructions. The JSON here is going to be code. It's going to be a string, the generated code. And then generate prompt, generate response, and a model is going to be GPT 3.5 turbo. Primers is definitely not a thing. Temperature, it's not going to go too creative here. Okay, cool. So we are gonna just have a string input here, which means sorry, which is just gonna be it's basically gonna pass in the whole current document, the whole idea. So let's just write it out. I have the following idea, and then let's just say idea. Idea. Please create a single view component using Tailwind CSS to generate to create a proof of concept of this idea. I'm gonna do it like super simple, and then we're gonna see what happens. So let's add the designer. In our workspace, we now need to adjust a few things. Let's see. So we have a designer who doesn't really do anything. But what we need to do is make sure when this is done, we're going to go to the designer, and we're actually going to give it the idea. So we don't really have, we need to kind of generate the idea again. So maybe we should just do that. Idea. Let's copy it. Sorry. This will be this state. Flows. User stories. I think this should now be, because it could still be idle. Yeah, this is just a typing thing as always. But let's user stories flow. User stories flow. Okay, cool. So we're giving it the idea, and then we should get some code back. So we can try. No, I just want to see it running, see what happens. So what we're gonna do is, oh yeah, render agent message. So we're gonna render the designer here, and let's just. Oops. So and then if I'm not gonna do this, we're gonna add Sampack, and let's see. How do we do this? Return chat content. Yeah, so this is like the flexibility we have now. So for each agent, we can now decide how to render the message. So going through the content, we render like text like this. We can render function calls. We can go and add content in between here. So we have a lot of flexibility that I'm very happy with. But yeah, let's see now. So import Sampack from that. Oh. Sampack. And now we have to give it like a template, which is view. I guess we can do view. And then we have the custom setup. I can't quite remember all of this. No. Let's see. I can't remember how we did all of this. Quick start. So I want to do view beat. Only preview. There we go. Whatever theme, layout, only preview. I'm not sure what the entry file is for this. Oh, so we can do... Oh. This doesn't generate the right thing. Okay. Let's see. Let's copy this. That was kind of weird. Sampack provider. Sampack provider. And then it was Sampack layout. Back layout. And Sampack preview. It's kind of cool how this is built. And then I'm a little bit unsure what like the main file is. Like what is the entry for view? Let's try opening the sandbox. Yeah, it's app view, source app view. Okay. Files, source app view, and then we're gonna take the message content, not content, but output code. Like this is we're reaping our fruits from doing this refactor. Like we can create this stuff very easily now, so this is awesome. But there's a piece missing here. We also need Tailwind CSS, and I can't quite remember because you can add static. No, where's that? Usage, file format, dependencies, npm, static external sources. Here it is. So we have options, and we even have Tailwind CSS as an example. Nice. So we have Tailwind CSS in there, and this is also because we're constraining the app to, like, we know it's Vue and Tailwind CSS, so we can actually create much better ways to validate with the user what their idea is and so on. Like pointing back to like discussions of the genericness of like something like Devin. Yeah, like how do you validate the intention? Because no, it doesn't matter how good it is at writing valid code if it can't evaluate your intention. Yeah. Cool. So now we have that. I think we can try it. Let's see. So we're gonna create like the interaction with the agents, like iterating. We're gonna use threads for that. So that's a good excuse to do threads. Approve. Let's see what the designer does now. It did pop up. This is so cool. Oh. Okay, so there's something in here. Failed to load URL. Yeah, so this is a Electron thing. I think I just need to add this to the yeah, content security policy. I think this is because of there's an iframe. Let's see, where do I have that policy thing? Is it here? Yeah, here it is. Default so script source, font source, image source, content security policy. Content security policy iframe. Frame source. So then we'll do frame self and boop. I think this is gonna work. I think maybe we can even just refresh it. Yeah, now it's downloading. Running Vite. Okay. Oh. We have another one. Okay, let's just add. Not sure how you do like generic. Well, we don't need like the full. I wanted to just use. Oh, we don't need Vite. I think that's the reason. Let's change the template. It should just be a view. We don't need like the full notebooks environment. Yeah, no, there's probably. Can I do like CSP? Like these aren't valid anymore. Can I do like code sandbox IO and then it will work? No, it has to be specific. Star? Can't I do... Does it have to be specific? Oh! Look at that, it worked. Can I actually add something? Yeah, look at that. That's really cool. Oh my god. That's super awesome. You know, I'm just gonna blow my nose and then I'm just gonna answer colleague, blow my nose, and check my calendar. Yeah, nice. We have a lot of time. This is awesome. So we're gonna continue the stream. I do need some food though. But yeah, let's. I'm just gonna help with a PR here. Okay, cool. Yeah, blow my nose. I'll be right back. Let's see. Okay, I'm pumped. Are you pumped? This is pretty cool. So what we're gonna allow is to we're gonna allow you to iterate on this by writing back to it, but then we need an assistant thread, I think, instead. But we need to figure out how to have generic. Oh, we did. It's asterisk. Okay, great. This is really awesome. Now the question is like, how do you iterate on this? So what could be really cool here is that we could allow you to draw on top of this. But I don't want to use the Vision API. It's expensive and it's still just text-based. It just throws out some text, and then I don't think that's the best way to do it. But I don't think it will be very good at actually. So, for example, yeah, we can try it. So let's bring back the assistance threads, and then yeah, this is really cool. So this is where you use, like, it's starting to look like something. So this is your flows. This is where you interact with the agents, and this is like the result of doing that in the main area. This is pretty cool. Yeah, by the way, I'm gonna put that thing in the center. That was pretty awesome. So let's say flex item center. Is that how we do it? No. Just justify center. How do we do that? There we go. Yeah, why doesn't it scroll? Isn't there like padding there? Anyways, doesn't matter. This is really awesome. Okay, let's bring back the assistant threads. So I'm gonna close it down. Let's just commit this. Wow, that's cool. What are we gonna? Yeah, assistant thread. So how are we doing this now? So as I said, we need to keep a reference to every we have these flows, and yeah, and this is the actual flow. So what we're gonna do is we're gonna call it router. I'm gonna rename this to router. Oops. Router. And then we're gonna have a thread. It might not be there because we're gonna create it as we need it, I think. Or maybe we can just make it a promise of a thread. Yeah, let's just do that. Let's see, assistant thread. Yeah, we're using assistant thread. Let's try this. Bloop. Yeah, but we can just create the one for user stories for now. And then create user stories flow. Where is it this? Oh. Let's use our new terminology. And then the thread is gonna be system thread create this.openai and assistant ID. What's the assistant ID? Let's see. I don't want to. I think I have it in a file locally, but I don't want to expose. I don't want to expose my. Let's see. Assistants. I think it's web dev, but this one now has a bunch of things. Yeah, by the way, we need the latest yarn and OpenAI latest. Has a bunch of stuff. I wonder if I was using this one. Yeah, I think so. Let's just use that one. But I can't remember what does this actually do. Yeah, it creates a thread. Exactly. Cool. Yeah, and I guess we need to create a thread for the other ones as well. Let's put this in a const. Cool. So now they have a thread each. So what we're gonna do now is let's rename this to current route. Oh, wait a minute. It is current flow. Sorry. Current flow router prompt agent. Yeah. Let's see. Router prompt agent. Let's just fix the typing here, and then we're gonna change how we actually. So on send prompt. So now we're saying this add message. But what we need to do is we need to know who is sending this. So we need actually the name of the agent that's sending it. And then I can't remember handle function calls. How did this work? Create planning router. Where is it? Create user stories router. So we have the function calls here. Oh, just my mother. Let's see. Agent completed. On send prompt. So how do we know? So let's imagine that we know. Oh, we don't care. Like we know this is, yeah, sorry. So we know flow dot, oh, we call it flow here. Create user stories router. Yeah, we should call it rename create agent router. Sorry. We have some terminology. Okay, so this is the user stories router. We could pass in the thread here. But I think we're just gonna, or we need to like test this. So thread would be, I know this is the user stories flow, user stories thread. So what we want to do here is, oh, await that, of course. And then we want to say add message here instead. Yeah, and we also need to pass in some more params. So I think we're going to take some inspiration from this message. So let's take this and then, yeah, on tool calls, we're going to integrate it into our assistant thread. We're going to basically implement this as an assistant thread. So I think we're just going to actually copy this, add message, and we're going to do that here. Let's see, add message. Yeah, we're gonna do this. Yeah, we'll just say as GPT model. And what we are gonna do, yeah, this is interesting because now there's really, yeah, let's call it current model. And then we're passing role user. So this is creating the message. And this is where a temperature model response format. So that would be JSON. Doesn't it have, I need to restart the server. Doesn't it have? We should have JSON now. How do let's look at the docs. API reference threads. Is it the thread or is it the runs? It's the runs. So yeah, it must be just yeah. It must be a typing thing. Response format, JSON, or undefined. Cool. And then we have context messages. We're going to ignore that. And then we have on tool calls. So currently when we observe the stream, we have on end and we fire this requires action emitter. But we're not going to do that. We're just going to pass it this on tool calls. So we're going to drop that emitter because it creates this decoupling that we don't want. On tool calls, and then we should be able to say yeah, we also need to be able to await the this is going to be interesting. Should we drop the stream? It's so much easier without the stream. I don't think it makes sense to have stream because we don't want an experience where you're not chatting with these agents in the same sense, and they typically produce JSON output. So we're gonna drop the stream. You know what? Maybe we can just use the code from. So we're gonna comment out the observe stream. I'm gonna keep it in case we wanna use it later. But we're just gonna take runs create, and then we're gonna have run, because this is the same. And then let's see, add message. So you know what? I'm gonna try to just copy this. Let's see. So we have a run here. We have send messages. So that means we will need to put our run here. So this will be await response. Is that it? Yeah, so this doesn't have. How do I get message? How do I get the actual? Let's see. Create run, a run object. Oh. Retrieve run. Oh, because you need to pull it. I remember now. Yeah, no, I think we should use the. Yeah, sorry. We are going to use our streaming API, but not because we actually want streaming. It's just, I think it's easier to put a promise around it, and then we'll resolve that promise when the stream ends. So observe stream. We're gonna return a promise from this. Return new promise. And this is where is this where we generate, yeah, the payment? Yeah. So this is gonna be message string, and usage is gonna be the usage. At some point we're gonna resolve this. Let's just shove the whole thing in there. Oh yeah, and then we final messages. Okay, so this is gonna be so I guess what we would do here is what would we do here? I think this stream final messages is what triggers the stream. I'm not sure. But this is a promise of, oh, wait a minute. I think we can do this. So when we have, yeah, okay. Stream final messages. So these are final messages. What we can do is return. Yeah, this is interesting. So this will resolve when it's done running. So here we could do usage, and that would be okay, but I think we can rather do it on final messages. We don't need to do it here. Let's see. We're gonna make this work. And then we're gonna return. This is actual usage. Usage. Oh. And then the message would be final messages, and then we just pick the first one, I guess. Content. Yeah, what is a run? I think a run is like a single message. But it can have multiple messages. Like it can do like a function call. And then it writes a little message. Then it does another function call. Writes a little message. And that's the problem here. Like we don't really want. Okay. Because what we did previously. Yeah, this is a problem. Like previously, we were just listening to the events coming from the stream, and we would like populate the messages array. So we get a function call, you get a message, you get a function call, a message, sorry. And then it would work. But now we wait for a full response here. So I wonder if actually we just need to change this to be the actual messages. But the problem is that Dag nugget. We have another problem. Is that this is fuck. How are we gonna do this? I think. Wait a minute. I think I'm doing this wrong. Create user stories router. So what if we have the thread here, and here we have handle function calls. Yeah. Wait a minute. I think I'm doing this wrong. We should keep this as is. We are gonna do this. We're gonna keep that like add messages thing that we did, but we're not gonna pass function calls in there. I'm gonna drop this one. And what we're gonna do instead is thread. Okay, this kind of sucks. Ooh. How are we gonna do this? Let's comment out add message first. Create user stories router. So we need a thread to, but we have a promise of a thread. We don't have an actual thread. But we instantiate this stuff. So I think we just have to thread promise. What I'm wondering is if we could even just do, did I do any thread like, yeah. Yeah, so we have on send prompt. Yeah, okay. So what I think we should do is we're gonna evaluate on agent completed. All of this stuff, we're gonna evaluate this within the thread promise. So basically, we create the agent router and return it, but then we're gonna say this flows user stories thread. Oh, we don't have it yet. Okay, this is complicated. So you know what, we're gonna say create, yeah, user stories flow, and then we're actually gonna create it, and then we're gonna create the thread inside the flow, and then we're gonna return an object of the router and the flow. This is how we're gonna do it. So what we do is const thread equals, and actually I don't think we need a thread. Yeah. Sorry. Yeah, this is nice because now create stories flow. Yeah. We don't need this. Oh my god. Because the thread doesn't need to be accessed anywhere outside. It's just part of setting up the router. So we're gonna do this. Did I mess up the types now? Did I do that? No. Why are you complaining? Where did I say you have to be? Oh, there you are. Let's see. There we go. I don't have to say router anymore. And no router here either. And what we rather need to do is and let's just keep add add message, so we don't have to like refactor. We're just gonna use assistant threads on create user stories router. Here we have the thread, and we're gonna return the router, and then thread. But when the thread is ready, and it will be ready immediately, we are gonna do all of this. We're not gonna prime agents. Yeah, maybe we should have completions as well. Like if we want to do some pre-handling. Yeah, I think that makes sense. But all of this, so on agent completed, on message change, all of that can happen. But handle function calls, that's part of the thread. So we're gonna put that inside this one. And then we're gonna put that last. So we create the thread here. We do the general like message change on agent completed, updating the state. But now when we're sending a prompt, so on send prompt is also going to be part of this. Because it's about how it manages on approve user story. That's also just state updates, which is fine. Yeah, so it's basically let's call this rename symbol thread promise, and this is the thread. So what we are going to do is, this is handling the function calls. So we're going to say thread on requires action. We are going to say tool calls. Let's see, it has run ID, and tool calls. And we are now, exactly. So now we're going to say handle function calls, or basically return handle function calls tool calls. Yeah, exactly. And then we need to wait for this because we're not going to return anything. We are going to say handle function calls. Let's just do async here. Function call output. And then we're gonna call our thread and say submit tool outputs. And the run ID is the run ID function call outputs. Nice. So that's gonna close the loop on that. And then we're gonna say thread add message. What was it? Was it prompt? Yeah, params. So this is gonna add a message, and it's gonna messages await. So this is gonna actually like kind of add the messages, but handle message done here with the message doesn't make any sense anymore. Because message done, it shouldn't include a message because, okay, so I've made that decision now. I think handle message done. Let's see. Is there more stuff here? Thread on. Yeah, I think I'm gonna do on message done instead. And then this gives the... Oh, it doesn't give the actual message. We can fix that though. Handle completed. Yeah, and these messages, I don't think it makes much sense. Yeah, so I think we're just gonna send... We're just gonna add the messages here, and then we're gonna do thread on completed. Router handle completed, and this is gonna have the usage. It actually has a model as well. Sorry, so this is gonna be usage. On message delta, router handle message delta. Yeah, because now we have message delta. Yeah, and this message done shouldn't really have the message. And we're not going to do this anymore. Let's fix handle message done. So this should come from... Yeah, I'm wondering about that. Let's see if actually the system thread handle message done emitter, does it actually have the message? Yeah, e dot message content. Yeah, so this is interesting. This is text. It's not message done. That's something else. We're thinking text done here. Yeah. Yeah, exactly. Yeah, this is... Yeah, it's not message done, because completed is when it's done with the whole run, like the whole like message thing. But this is about like... Didn't you say string? Oh yeah. Oh. On message done emitter. Let's give it actual text, the finalized text, and then text. Yeah, and this should be... Yeah, because I'm confusing message with text. So this is really text. And message is the whole thing, I believe. Maybe... yeah. Let's... Yeah, I should probably remove that confusion. A message is really text. Yeah. Okay, cool. So I think this is gonna work. It doesn't look like it, but I think it's gonna work. Let's see. We're gonna work on this until it... Well, we probably had some errors, right? No errors. Okay, so we do have some errors missing. Tool call ID. Okay. So handle function calls. Does this return handle function calls? Blah blah blah. Oh yeah, sorry, it's in the wrong format. So we need to map over these. Map to... What does it have here? It has a ID. D, and we just need the output. So this should be tool call ID is ID, and I think it's just output. Yeah, now we see it streaming, which is fine, but it works. We can see the amount of tokens blowing up a little bit though. It's just what happens for some reason using the assistant, but it's not like bad. But now I should be able to like more naturally interact with it. So let's see. Let's check that before I eat lunch. No, you know what? We're gonna say it's working now. And I'm just gonna eat some lunch. And then I'll jump back in and we'll do another stream. And our goal then is to test the interaction. So we can just talk to it normally, because that's handled by the context thread. And then we're gonna try to interact with the designer to get kind of the visual design out. And when that's done, we're gonna add the actual thing here. And then we're gonna try to run the tech lead over the whole thing and see what the tech lead says. And when that's done, we're just gonna look at the result here and just talk about it, evaluate it. Does it reduce ambiguity? What improvements could we make? And so on. And then we need to talk about the next step, which is the planning. Like, what does it mean to do planning? So for me, I really like this idea of go and grab the files. Yeah. There's something about writing the specification as code comments. I think there's something to it. Instead of like just writing in text what should happen, we write it in the actual code. Yeah, I'll think about it during lunch. But yeah, I'm super happy about where we got with this now. This is awesome. It also makes me think it's good to take a break as well. So I'm kind of happy I got... Well, I'm not happy I got sick. It's horrible being sick, having 2 small children, especially during the weekend. It's just horrible. But yeah, the upside of it is that I was able to reflect a little bit. So that was nice. Okay, see you later.